my name is Dustin. I'm a student at the University of Tennessee in the United States, which is located in Knoxville. I'm a graduate student, which means that I've been in school for a very long time. I went ahead and finished university to start with, and then I moved on to a PhD program. So I'm in the middle of my PhD program currently. And one of the cool things about my PhD program is the fact that it lets me work at the Oak Ridge National Laboratory. So Oak Ridge National Laboratory is one of the national labs in the United States, run by the Department of Energy and the University of Tennessee. And what's really cool about Oak Ridge is that they get to study a lot of different subjects. So as they study things like nuclear reactors, neutrons, which are really small particles, and 3D printing. So I study 3D printing at Oak Ridge National Laboratory. And in the pictures you see here are some of the things that Oak Ridge works on. So on the far right is a robotic hand. So Oak Ridge works in robotics. And all of these objects were actually 3D printed, which is really cool. So they 3D printed a robotic hand that's able to be manipulated and move objects. They 3D printed the car on the top left that you can see, and they even printed the bottom left, which is a sandcastle. So I actually did that printing, so you can print things out of lots of different materials, and we'll talk a little bit about that today. So I'm going to do a little bit of an overview of 3D printing and do a little bit of an explanation, and hopefully end with a few of the things that are possible with 3D printing and where the future is going. But first, I'm going to take a step back and talk a little bit about how you make things. So I'm going to start with how you make an everyday object. So do you all have Legos? Have you all played with Legos?
I love playing with them.
You love Legos?
They're
awesome.
pretty fun.
I play with them every day.
Awesome. The Legos are little plastic bricks. But how do you all think Legos are made?
3D printer.
3D printer? That's one way to make them.
A machine.
I'll go ahead and start. There are 4 ways to make things. And these are kind of big, broad umbrellas that other processes go under, but they kind of capture the main ways of making things. So the first way, and I'll go through these, and then I'll let you all guess how Legos are actually made. So the first way is subtractive manufacturing. So this is my poor drawing of a saw kind of cutting material off. So in subtractive manufacturing, we're removing material to make the object. And you can see a really cool example of this is woodworking. So if you all like to do wood shaving or any type of woodworking projects for like tables or chairs, I know my grandfather really enjoys whittling. So he takes pieces of wood and removes the shavings until he has things like whistles or trains, which takes a long time, but he really enjoys it. Another way to make things is casting. So casting is where you take liquid and you pour it into a mold and it solidifies. So this is normally done with metals. So it's done with hot metal, it's poured into a mold and then it solidifies. And a lot of car parts are made through casting. So if you have a car at home, the chances are that most of the components in the car were made through casting, which is pretty cool. And then the third way is forming. Forming is a lot like using Play-Doh. So I'm sure you all probably played with Play-Doh before, but what you do is you take it and you manipulate it into the object that you want. And if you're doing this on a large scale, what you're going to do is you're going to use a machine to do it. So you're going to take something like your material. So in this case, it would be a plastic. You're going to put it into a mold, and then you're going to apply pressure and your object will pop out. In this case, it would be something like a Lego brick. And this is done on an industrial scale and in many different forms. But it would look something like this. So this is one form of forming where you use compression molding, where you're taking an object and you're applying pressure using an upper half on a bottom half of a mold, and then you're going to eject your object. So which one of these ways do you all think is used to make Legos?
Forming.
Forming? That was a really good guess. That's right. So forming is how most Legos
What's the
are made.
fourth way, though?
I'll talk about the fourth way in a minute. First, I'm going to show you all actually how Legos are made. So I have a small video that we can watch. It's really quick, but it talks about how Legos are made. And if you all are ever interested in how anything is made, there are videos online. It's how it's made. You can probably find them on YouTube or other sites where it'll show you exactly how these are made industrially, how big companies make these objects. So I'm going to go ahead and play this video for you guys. Hopefully it works. Oh, it's going to take me out. Let's go back. Oh, it's not working. Oh, no, there it goes. Those are made industrially. So it's a really cool process. They make millions of bricks a year, and you can see that they then take them and ship them all over the world. But you were right, I did miss a way of making things. So another way of making things is 3D printing. So in 3D printing, what you're doing is you're taking that material, that plastic, and you're laying it down layer by layer by layer to make the object. In this case, your Lego. So when you're adding these layers up and up and up, what they've done is they've decided to call this additive manufacturing. So it's a contrast to subtractive manufacturing where you're taking away material instead of adding it. So I'm going to talk about it as additive manufacturing instead of 3D printing, because that's kind of the term that I'm used to using. And you can see here an example of where they're taking this plastic and extruding it out to make something like a Lego brick. So why would you use additive manufacturing for making Lego bricks instead of forming? So you can see that industrially they use forming, but why would you want to use 3D printing instead? So there's a lot of reasons, but one of the main reasons that you all probably didn't notice in my poorly drawn picture is this. So this is a mold that they use to make these parts. And if you want to make a different type of Lego instead of a brick, you have to have a different type of mold. And these molds are called tools, so they call it tooling. So it's really important to know that if you want to make something like the person instead of the brick, you have to have a different mold. And these molds are kind of hard to make, so they have to be made by hand, and it's time consuming and it's expensive. So that's one of the biggest advantages of using 3D printing to make these bricks instead of using a normal method like forming. Now, forming has its advantages. It can make a lot of these bricks really fast, as we saw in the video, but you can make lots of different types of bricks using 3D printing, which is really cool. Another advantage is the fact that you can make these using 3D printing wherever you want. So instead of printing them in Denmark or making them in Denmark like Lego does, and then having to ship them or having to fly them or taking a train to move these from Denmark to wherever you are, like in Canada, they will instead just print them on the spot. So if you have a 3D printer at home, you can print Legos. You don't have to go to the store and buy them. And this fact means that there's less waste. So you're having less Legos being moved across the world. You have less Legos in the store that aren't being bought. And even in some facts, you have less plastic being used. So 3D printing, these are some of the biggest advantages that you see. And this is exactly what the inventor of 3D printing was thinking when he first started this process. So this is Chuck Hull. He is the inventor of 3D printing. So he invented the very first process way back in 1986. So he was thinking this exact thing. He wanted to make a prototype. So he wanted to make something that had never been made before. But the problem with this was he didn't have the tools and the supplies that he needed to make this. So instead he thought there has to be a better way. So what he did was he invented a new way of making these things. So his invention is probably not what you were thinking of as 3D printing, is where you took a laser and you melt layers of polymer together to shape what you want. So this is one of the forms of 3D printing or additive manufacturing that you use. And it's not what we normally think of, but it is the very first one that was invented. So it's really interesting. And he did this because he worked at a place where they used lamination. So he took small films of polymer and would laminate either paper or put it on tables to keep things from getting scratched. So this is what he knew how to do. But what we think of 3D printing today was invented by Scott Crump. Scott Crump invented what we think of as 3D printing today in 1989, and it was called material extrusion. So material extrusion is where you're taking a plastic and extruding it to make a part instead of melting it layer by layer, as you can see in the top picture. And Scott Crump went on to found a company called Stratus. That's a company still today. They make industrial 3D printing machines that make parts that are very strong and very accurate. Not what we would normally think of as a desktop printer today. And these were just 2 forms of 3D printing. So there's actually 7 forms of 3D printing, and I'll get a little bit into that later and kind of describe the different forms for you guys. But all of these forms kind of share the same umbrella term. So they're all under the same type of definition. It's a process of joining materials to make parts from 3D models layer by layer. And this is very different than subtractive or formative manufacturing that we talked about earlier. And they all follow the same type of process. So this is kind of an illustration of the process that you would go through to make a part. You would start with a CAD file, which is a digital model of your part. And there's a lot of different ways to do CAD models. So you can use things like Tinkercad on your computer. And I don't know if have you all ever made a 3D model on your computers?
No.
No? So it's really cool. It's a really interesting way to start making things if you're interested. So almost all things that you have in your house started out as a model like this. And there's a lot of free software you can use. So if you're interested in something like that, it's really cool to make these 3D models. There are models online that you can use, but if you ever want to 3D print something, you're going to need one of these models. So you're either going to have to find one online or make one yourself. And the cool thing about making one yourself is that after you've made the model, if you have a 3D printer, you can print it. And once you print it, you've made something new, which is pretty cool. So after you've made your model, then a file will slice it, which will show what every layer will look like on the 3D printer. You'll put the file on your printer. So a lot of times this comes as built-in software, so you really wouldn't have to worry about it. And then you'll set your machine up, and then you'll do your build. Then you'll take the part and remove it and do whatever you need to do to it. A lot of times they'll sand them to make them more smooth or other things, and that's what they mean by post-processing. And in this case, it was a cup. So then you have your cup to use, which is really cool. So this process is kind of unique for 3D printing because it's so fast and it goes so fast. You can build things and then iterate on the design. So here you can see an initial part on the top left, which is what a part would normally look like if you were going to design it industrially. It's kind of boxy. It's a lot of material on it. But if you want to design this for 3D printing, you have a lot more freedom. So you can remove a lot of the material. You can make it more rounded, more organic. And that's exactly what they did. So they tested this part over and over again, and then they went back and redesigned it over and over because of the fast design curve on 3D printing, which is really cool. So you can make parts that are more efficient, more lightweight, and kind of just better than other industrial processes, which is really cool. So like I said, there are 7 forms of additive manufacturing, and where it really differs is in the build. So it's how these parts are being built. I'm going to go over all 7. They're kind of complicated, so if y'all have any questions while I'm explaining these, feel free to ask me. And I'm just going to kind of graze the surface. There's a lot of science that goes into this, so that's kind of what I study. There's a lot of material science and physics and chemistry that go into these parts. But I just kind of want to make you guys aware of what's out there and what's going on. But if you have any questions while I'm going over this, just stop me and I'll do my best to explain it. So the first one I'm going to talk about is powder bed fusion. So this is a lot like what Chuck Hull invented way back in 1986. He took a laser or a form of energy, and he was melting these particles together to form the part that he wanted. So I have a video of this right here. We'll watch really quick. And what you can see is these bright spots is the laser moving back and forth very, very quickly. And it's going from a light color to a dark color because it's melting these powders. So this is a metal powder that's melting together. And a lot of times that's what it's going to do, is going to be a metal powder, because there's a lot of prediction you can do to make these parts really really good for an industrial use. So you can see it doing it over and over again, and then it's going to spread a new layer of powder. So that was layer 1. It's going to do another layer, layer 2, where it's going to do the same thing. It's going to heat the powder and then do laser and melt the powder together. So another way to do this is using direct energy deposition. So this is another form of additive manufacturing where you're taking the same type of laser, but instead of melting a powder bed, what you're going to do is you're going to melt a particle. So they're going to shoot a particle of metal into the laser beam and melt it on the specific site where it's wanted to be melted. A nice example of this in everyday life is, I don't know if you all know anything about welding, but this is really similar to welding. And in welding, you're taking usually a piece of metal and using energy to melt the very tip of it. And you're taking that tip and adding that metal to another spot. So here you can see this is just kind of like a big MIG welder on the end of a robot arm that's moving around. So it's building up this part layer by layer by layer, really tall. And that's one of the advantages of this process, is the fact that you can make really big parts. So they use this to make really big pieces of metal. And the third one is binder jetting. So binder jetting is actually what I studied. So I can talk about this process for a long, long time, but I'll try to be kind of short. So binder jetting is really similar to what you all have at home with your printers. So there are inkjet printers at home that you use probably that are depositing ink onto a page to make a picture. Binder jetting is really similar to that, but instead of doing it on paper, it's doing it on powder. And it's binding those powder particles together into a picture. And then it's doing another layer of powder and doing it over and over and over again to create a three-dimensional object. You can see that at the bottom here. You can see it moving back and forth, and it's going to make kind of a square in this picture. So it's really interesting. This is more of an ink that is spreading on this, actually. So it's a layer of powder, and I think this is just an ink cartridge that's being used to create this image. I'm going to skip forward a little bit so you can see the final image. So it's just a big square. And you can also see it doing the next layer of powder. So it'll spread another layer. So right here. So it's spreading a whole nother layer of powder across right here. And then it's going to do the same thing. It's going to go back, and you're going to see it start printing again. So the dark part's where it's printing, which is really interesting. I really enjoy this form of additive manufacturing. It's my personal favorite since I'm studying it. And if you have any questions about this one, I can go in depth on it. So moving forward, so actually I'm going to go back here for a second. These were grouped together for a reason. So I grouped these all together because they usually use metals. So there are a couple different ways, materials you can make out of 3D printing. So there are polymers or plastics, and they're metals, and they're ceramics. So these methods are usually used to make metal parts. And the reason you want metal parts is because metals are really strong and they have really good thermal properties. So in other words, they're not going to melt when you get them really hot, like a plastic would. So these are used for applications like your car engine. So in a car engine, metals are important. Yeah, do you have a question?
What about the other four?
You mean polymers?
Other four forms of additive.
Oh, the other forms? The other forms usually use polymers instead. And I'll do a little bit more in depth on polymers after I talk about the next forms of additive manufacturing. So these are using metals, and that's why I grouped them together. This next group uses polymers. So that is a different type of material that you can use to make objects out of using 3D printing. The first one I'm going to talk about is material jetting. Material jetting is really similar to binder jetting. And that's why I did it right after binder jetting. So it's similar to what you use at home with your printer. So it's laying down layers of ink. In this case, though, it's a lot more similar to your home printer because it's not laying them into powder. So it's not binding powder particles together. Instead, it's laying it onto usually a glass surface. And what's happening is these polymer particles or polymer droplets are going to be solidified. So they're going to use a form of energy, usually it's UV, so kind of like sunlight, to become solid from a liquid. And that allows you to build up a three-dimensional object. And you can see that here in this video, where they're going back and forth over and over again on this object to build it up. You can see the UV light out in front, which is solidifying it after the particle droplets are laid. You can see it makes a pretty big part, which is really interesting. So that's another form that uses polymers. Another way to do this using polymers is vat photopolymerization. So that's a really long word, but photopolymerization just means you're using light energy to solidify a polymer. So in this case, you can see it's a laser, but it can also be a lot of different forms of light. It can be kind of like a movie screen, or it can be sunlight, a lot of different ways to solidify these polymers. And the video below here is actually a special type of vat photopolymerization called clip. So this was invented by Joseph de Simon very recently, and he takes oxygen and light, and they form a polymer part out of it. And it's projecting the light from the bottom, and it's pulling the part out of the vat of polymer. And it's really quick. That's why this is a new process. So you're going to see it makes the part in under 10 minutes, which is really, really fast. If you were doing this using material extrusion, or what we normally think of as 3D printing, it would take a long time, probably hours, to make a part like this. And you can see in under 10 minutes, he's made the Eiffel Tower, which is really cool that he can do it so quickly. And he commercialized this process and founded a company called Carbon 3D. So this is one of the coolest forms of 3D printing that I've actually come across. Another form is material extrusion. This is what we normally think of as 3D printing. It's where you take a plastic and you melt it, and it comes out of a nozzle. And that nozzle is going to build up the part layer by layer. You can see an example here below. And it's going to form it back and forth, layer by layer by layer. And this is in high speed, so it doesn't actually make the part this quick. This build will take probably a couple hours to do, but it's really cool because it can build it up layer by layer. So you can make really interesting parts like you see here. And I put this in because the Department of Energy sponsors our work at Oak Ridge National Laboratory. So I was kind of just showing you what the Department of Energy does. So these three, and then the final form of additive manufacturing also uses polymers. It's called sheet lamination. Unfortunately, sheet lamination, I couldn't find any cool videos for it. It's kind of a reason for that though. So sheet lamination is where you're taking sheets of polymer usually and stacking them over and over and over. And while you're stacking them, you're going to selectively bond these sheets together in certain places. So you can see here that it's a ball, but it's bound layers of these sheets. So part of the problem with sheet lamination though is that you then have to remove all of this excess material. So sheet lamination uses subtractive manufacturing to remove these excess layers. So it's more of a hybrid type of process than a really true additive process. So it's really kind of interesting though. So throughout this slide, I've been talking a lot about polymers. So polymers are a little different type of material, and I don't know how much you guys know about polymers. Do you all know anything about polymers?
No.
No? Okay. So I'll do a little bit of a background on polymers then. So polymers are plastics. So anything in your house that is plastic is made out of a polymer. So your Lego bricks, your sometimes cups, and lots of different objects. And the reason that they're made out of plastics is because polymers are really formable. So they can be made into lots of different shapes very easily, just because of the properties they have. And they're called polymers because they're long molecules. So the difference is, so water molecules are small. You can see they're made up of 3 parts. But polymers are made up of many parts, so macromolecules, big molecules. And they're called polymers because poly means many. And it's because they're made up of many monomers, many small molecules. So you can see here, these monomers are being chained together to make a long polymer, which is really interesting. And polymers were a pretty new invention. They think they just celebrated their 100-year anniversary, which is really cool. But they are really versatile materials. And there's a lot of people still studying polymers today because of the different things that can be done. And the reason that polymers are so useful is because a lot of times their properties are determined by the length of their chain, how long these molecules are, how big they are. Whereas in a monomer or a smaller molecule, it's really determined by the chemistry. So what different constituents they have made up of. So polymers can have properties like they can be moldable, so at low temperatures. So in the video you heard 253 degrees C. So at 253 degrees C, the polymer will melt and you can form it into any shape you want. If you were using a metal, that temperature would be much higher. So you'd have to use a lot more energy to form it into what you wanted. They can be really strong. They can also be rubbery. So all rubbers are polymers. So if you have a bouncy ball or anything like that at home, or even a basketball, the reason they bounce is because of a polymer, which is really interesting. And at the end here, I'm going to talk a little bit about the cooler things you can do with 3D printing. So is there any questions so far about anything I've covered? So if there are any questions, I'll go ahead and move forward. And I'll talk a little bit about some of the cooler things you can do with 3D printing. So at Oak Ridge, where I work, there's a place called the Manufacturing Demonstration Facility. There we have a printer called BAM. And BAM stands for Big Area Additive Manufacturing, but it's a cool acronym. So it's a really, really big 3D printer, similar to what you would have at home, but on a huge scale. And in this picture here, you can see some things for scale. So there's some people out front here, and there are a lot of different objects around that you can kind of see how big this printer is. And BAM is used because we want to print really big objects. So an example of this is a car. So this is the car that I showed at the very beginning of my presentation. And what Oak Ridge did is they printed the entire body of this car. So the whole chassis, all the blue part was 3D printed. And it looks really nice because they did a lot of finishing. So they sanded it and painted it and made it look really nice. But you can kind of see the outline of this being printed here on the left, which is really cool. And they added an engine and tires. And what's really cool about this car is it actually runs. So we had the President of the United States visit Oak Ridge National Laboratory, and he got to drive the car around. It was really cool. This is a really cool thing that we've been able to print. And if you were making this car normally, it would take you a long time to do it. So in normal car manufacturing, they go through a process of doing tooling and putting lots of different machines together to make their cars really fast. I don't know if you all have ever seen somebody make a car. I would recommend looking it up online. It's really cool. It's an assembly line really similar to what you would have seen back a long time ago with Henry Ford and the Model T. But it's really fast. And the reason they can do it so fast is because they've created lots of different tools and lots of different processes to make it fast. This car was printed in a weekend. So they went from design all the way to having a fully printed car in one weekend, which is amazing. So they didn't have to do all of the tooling or all of the optimization to make this really fast. It was just fast to begin with. So that's a really cool way you can make cars now. And there's a company located in Knoxville that actually is looking at 3D printing cars, so making cars customized for people, which is a really cool new business model. Another thing you can make on this machine is a house. So Oak Ridge printed a house not long ago. You can see it here on the left. And they also printed the car here that you see. And this house was special because they used solar panels on the top, and that's where it got all of its energy. And what's really cool about it is that it would share that energy with the car. So it's an electric car. I know you all did a pop-up lecture on electric cars and artificial intelligence in the car, so self-driving cars. And this was a really cool way for the house and the car to share energy. You can charge your car, or even the car can charge the house if the house doesn't have enough energy. So this was a project done at Oak Ridge. It was really cool. So in the future of 3D printing, printing houses is actually one of the coolest applications that you can move into. So this one, instead of printing plastic like is printed on the BAM, prints concrete. So concrete is being printed as well. There are a lot of companies actually looking at 3D printing houses, some in the US, some in other countries. But by 2030, Dubai, which is a city in the Middle East, has committed to having 25% of their buildings 3D printed, which is pretty cool. So this isn't too far in the future. So this technology is going really fast. So it's pretty cool. Another thing that you can do with 3D printing is you can print in space. So a company called Made in Space sent a 3D printer up to the International Space Station, which is really cool. And they printed this wrench there. And the reason you would want to be able to print in space is because it's hard to get them tools. So if you want to have a tool on the International Space Station, they have to send it up with the astronauts. But if they don't send it up with the astronauts, they have to wait to send it up again when the next rocket launches. So that could be a long time that the astronauts are waiting for a very specific tool. So by sending up a 3D printer, they can print any tool they need whenever they need it, which is pretty awesome. Another thing NASA is doing. Oh yeah, go ahead.
Can you print a BAM with a BAM?
You can. So I was going to talk about that later, but one of the most interesting things you can do with the 3D printer, most interesting things you can print, is you can print another 3D printer. So you can print all of the things you need, except for maybe the motors, on the BAM to make another BAM. So pretty much any 3D printer can do that. A lot of people will take their 3D printers at home, so just the normal desktop extrusion 3D printers, and they'll print parts for their printer on the printer. So they can take parts off and replace them with things they've already printed. There are a lot of videos of people replacing a whole printer with 3D printed parts, which is really cool. But it's the only manufacturing process that can replicate itself. So you can't make another mold with a mold using forming and different things like that.
You can't make another car with the car.
Right. So it makes it really cool.
You can't make another person with a person. So you can with two people.
You can with two people, that's right.
But not one.
Not one. So NASA has also 3D printed food. So they 3D printed pizza to feed astronauts, and they're hoping to do this in space. So that is one of the cool things you can do. Another cool thing you can do in 3D printing.
Does it even taste good?
I don't know how it tastes, but I know that you can 3D print chocolate, and chocolate tastes great.
Because how would they put the taste in it?
So they can do things like cheese. You can melt the cheese when you're printing it, and it's still cheese. You can print sauce, because sauce is kind of liquidy anyway, so it'll go through the nozzle pretty easily. The hard part, I think, is the dough. I don't know how they printed the dough through the 3D printer, but I would imagine it tastes pretty good. I don't know if you all ever had astronaut food?
No, I have not had astronaut food.
So astronaut food is dry freezed. So they have food that they send up to the International Space Station that they use dry ice to freeze it really, really fast. And then you can put the water into it. So it's removing the water and then adding the water back. But I've had some and it's not too tasty. So I think the pizza would probably be better, in my opinion. But I would prefer chocolate. So chocolate's something else they 3D print. You can see in this picture here, it's a really cool chocolate printed part, and you can eat it. So that's the best type of 3D printing, is something you can eat, because you can't eat the plastic. Another thing that's really cool you can do with 3D printing is you can print cells. So what you really are looking at is them looking to 3D print body parts. So this is research that was fairly recent, where they 3D printed a heart. So what you do is you take human cells and you 3D print them into a liquid, usually a gel, and they assemble together and to form a tissue. And this tissue will then form an organ. So this was a heart they 3D printed in Israel. Really cool research they did. And you can see that it actually pumped. So it pumped blood. So this is the first 3D printed organ that's
I have
ever
a
pumped
question.
blood. Yes.
Can you 3D print heads?
So to 3D print a whole head, you would have a lot of different types of tissue and a lot of different types of cells being printed. So that's what makes something like that really hard. It's something that people are working on, but it makes it difficult because there's lots of different tissues around your head. So you have your brain, you have your skin cells, you have bone.
Is it easier to print a body or an eye?
It's easier to print something like
Body or an eye?
something like an eye, because an eye is an organ. So organs are smaller parts of
Which
the
one
body.
do you think would be harder? Printing a body or a head? Which one do you think would be harder?
A whole body would be very hard because the whole body has a head on it.
Not the legs and the arms. Not the legs and arms.
Not the legs and arms, just your body.
So you're saying you could basically, you could basically make a baby with a 3D printer.
We're not quite there yet. That would be really hard. So they don't have that understanding to do something that complex yet. This is looking more at body parts. So things like kidneys and hearts, maybe even eyes someday, because a lot of people.
What about lungs? Lungs. Could they do
Lungs.
lungs?
Lungs are complicated because they have a lot of vasculature, a lot of blood vessels.
I have a question.
Yeah.
What about brains? Can it print those?
So brains are probably one of the most complex things in the human body. So they
I
haven't
thought you
gotten
said the
there
head
yet.
was more complex.
So the head's more complex than the brain, but the brain's in the head.
What's the most complex part?
So it's probably all of these cells being in close contact with each other, but
What's
doing
the
different
hardest
things.
part to make?
The hardest part to make. I'm not sure. I would have to think about that. I don't know if I have a good answer for that.
What do you think the easiest part to make is?
Nothing.
So I know one of the first things they did when they 3D printed a body part was they did a kidney. And the reason that they're really interested in doing kidneys and hearts is because there are people that need replacement organs, things like kidneys. And if you can print these, you don't have to take them from somebody else. So you can put these donors or these people that need these organs, and you can use 3D printed parts instead of taking them from somewhere else. So that's why this is really important, and they're trying to do a lot of good with it.
How long do you think it would take you to print this?
In the paper, and to print the monkey. So
Yes.
the problem is that the monkey's soft, right? He's not made out of plastic. So since the monkey's not made out of plastic, it would be hard. If you wanted to make it out of plastic, it would probably take you several hours to print something that big.
How long do you think it would take if you used, if you made him how he is without plastic? How long?
So fabric isn't something that we've really figured out how to print yet. So I don't think we could make him out of fabric.
I think the eyes would be pretty easy to make because they're not fabric.
Yeah, the eyes are made out of plastic. They would be easier to print. Do you have any more questions about the 3D printed body parts?
No,
I
I
have
think
one
I've
more.
asked enough questions.
That's okay.
I've already asked thoughts.
That's fine. The last thing it's in the future of 3D printing is something called 4D printing. So because you can add material in very specific ways in 3D printing, you can add different materials at certain spots. And there are a lot of polymers that respond to different stimuli, things like light and heat. And what they'll do is they'll either contract or expand based off of what they're experiencing, things like light or heat or cold. So if you put these in specific areas, when you expose the part to stimuli, it will change shape. And that's what they mean by 4D printing. So this is a new area that's being explored, making shapes that will change with different environments. So it's a really cool new avenue in 3D printing.
I have one more question. Do
Yeah.
you think 5D printing would be stuff moves if you say a certain word? Do you think that would be 5D printing?
So I don't know. I know that they call it 4D printing because it adds the dimension of time to your print. So 1D is like a piece of paper. 2-dimensional is like 2 different lines. So you have lines that intersect. 3D is the depth adding to that. And then 4D is adding the dimension of time. So I don't know if we found a 5th dimension yet.
What is the dimension of time?
That's your 4th dimension. So it changes with time. So that means it changes with stimuli, or like if you start a part, you have it sitting on your table, and you come back an hour later and it's changed, that's the dimension of time.
So
Okay.
you could use that to make an engine.
That is something that people are doing, yes. They
So you
will
could make a
add,
car with only 3D and 4D printing.
that would be really hard. So you would have to make the engine, and engines are really difficult to make using 3D
But
printing.
it's easier with 4D printing because 4D printing makes stuff that moves.
It's similar to that, yeah. We haven't quite gotten to printing a whole car yet. We've printed the body of a car, but we've not printed the whole car yet. So that is all I had in the future of 3D printing, but I'd love to answer any questions you guys have.
With printers that have a smaller nozzle, are they
Mhm.
more precise?
Yeah, they are. So I can go back to where I talked about material extrusion here. And you can see that it's extruding your polymer. So if you have a big nozzle, your layers are going to be big. And if you have a small nozzle, your layers are going to be small. So that smaller nozzle allows you to have more accurate layers. And that layer is what defines how smooth and how accurate your print is.
Do some 3D printers have more than one nozzle to be more efficient?
Yes, some do. When you add a nozzle, it's really interesting. So they added a nozzle actually to the BAM here to try to make it faster. The issue though is that you're heating polymers up at different rates. So when you're laying another layer of polymer down over top, a lot of times that causes issues. It'll cause your polymer to warp or change shape. You have to be very careful when you add a second nozzle. You also have to be really careful to make sure the nozzles don't crash into each other. So that becomes a software issue. So there's a lot of software engineers that work in 3D printing because of problems like that. So there's a lot of, I know you all have been studying code, there's a lot of code in 3D printers to show how you're gonna move your nozzle around, which is a really interesting application. Any other questions?
What type of code do you use for 3D print?
So I know a lot of printers use G code or machine code. It's a really specific coding language that you can learn. I am not a very good coder, actually. So I do know some code, but there are people that use other types of languages as well. But I know that you can use G code and machine code to move your printhead around. Does anybody else have any questions?
What are the most common things 3D printers are used for?
So it's mostly to make things for hobbyists. So for people at home that want to make something interesting or something new. They've also are really used heavily in prototyping. So when you make the first part of something that you've invented, they'll use 3D printing a lot because it's really fast. And then you can kind of get an understanding of how your prototype will look, how it will act, what you need to do with it before you invest really heavily in manufacturing it in another method, because the other methods are very expensive. So that's one of the biggest applications of 3D printing. Another application of 3D printing that we talk a lot about at Oak Ridge is tooling. So like I said in the very beginning, when you're using forming, you need a tool to form the shape. What you can do is you can 3D print that tool. You can make it out of plastic or another material using 3D printing. And that really cuts down on the time it would take to make that tool by hand, which is how it's normally made.
Is there stronger materials that you can use to 3D print?
Yeah, so plastic is one of the most common materials because it's easy to use. It's available, but you can use metals. So if you go back to the processes that I was talking about, you can see here, these were all polymer parts, but these were all using metals. So metals are really strong and they're used in applications like cars, jet engines, a lot of different applications. And they're used for their strength. And that's why they use metal 3D printing usually. These machines are really complex though. So they're a lot harder to use than a normal 3D printer. And a lot more expensive. So did you all like 3D printing? Do you think it's cool?
I once did it at a camp, and yes, I really enjoyed it.
Awesome. I know a lot of people are moving it into schools. I think it's going to be a new way of manufacturing in the future. And the more people that are interested in because I think a lot of people are going to be doing it in the future.